In this video, we'll create a custom input response map that will allow us to explore a 3D environment using a virtual reality headset and controllers. Let's start by creating a new experiment called VR Experiment. Let's first navigate to the experiment settings window and enable virtual reality since we're going to create a VR experiment. We'll also set our controller objects to hands. Now let's create a task for our participants to familiarize themselves with the 3D environment. For this experiment, we're going to use a mountain village environment, so we'll call our task Explore the Village. Whenever we're creating a 3D task, we need to add a scenescape. Scenescapes are the non-interactive portion of our 3D environment. We'll create a new scenescape called Mountain Village. To add our mountain village, we'll click the Object button to add a new object to our scenescape and select the Mountain Village model. We can press the Edit button on our task to see our scenescape. Now we need to create an object that the participant can control and move around the environment. To do this, we'll create a new responsive object and name it Participant. We'll create a new interaction tag by the same name and set its height to 2 units and its radius to 0.25 units. 1 unit is roughly 1 meter or 3 feet. In order to control this object, we need to navigate to the Input Response Maps tab. We'll click on the VR controller icon and create a new VR input response map. Input response maps cause the object to respond to inputs from our VR controllers. We'll use the left-hand joystick to move the position of the object. To do this, we'll add an object update response to the x-axis that moves the position of the object left and right by 5 units per second. We'll click the graded button so that the participant can control the speed of the movement by moving the joystick more or less in either direction. We'll also add an object update response to the y-axis that moves the object forwards and backwards by 5 units per second, and just like before, we'll click the graded button. We'll use the right-hand joystick to control the rotation of the object by adding an object update response to the x-axis that turns left or right by 150 degrees per second. Once again, we'll click the graded button. Let's navigate back to our task and click on the responsive objects to add our participant object to the task. We'll click Edit to see what our task looks like so far. We can click the Move button to position our participant object. We can see the size of our participant object by checking the Show Gizmo box. This will allow us to place the participant object flush with the ground. We can then click the Rotate button to adjust what direction the participant will face at the start of the task. The red arrow shows the forward-facing direction. Once we're happy with the position and facing, we can click the Save Position and Save Rotation buttons. This will set the starting position of our participant. Next, we'll click on the Visual Perspective tab and create a new visual perspective. We're going to create a first-person perspective, so we'll call our new visual perspective First Person. We'll set our target object to the participant responsive object. The target offsets allow us to adjust where the camera will be relative to our participant object. For the position, we want the camera to be positioned at the center at the top of our object. We see that this is the default, so we don't need to change anything. To track our participant object's movement, we'll turn position and rotation tracking on for all axes. Now let's test everything out by clicking the Run button. We can look around and we can see our hands. Cool! Let's move around the environment a bit. I wonder what will happen if I try to climb this rock. Oh no, it looks like I'm floating. That's because we forgot to enable gravity on our participant. That's okay, with Experimenter we can make real-time changes to our experiment. Let's navigate to the participant responsive object and check the Use Gravity box and set our mass to 50. Now we're back on solid ground. Let's try climbing the rock again. This time we see that we fall back down to the ground. Great! Let's do some more exploring. It looks like we can walk right on top of this table. Let's fix that. We'll go to our participants' movement parameters and reduce the max step height from 1 to 0.3. Now we simply run into the table and can't walk on top of it. Perfect. It also seems like our movement speed and rotation speed is a little too fast. Let's navigate to the Input Response tab and reduce our movement speed from 5 to 2.5 on the X and Y axis of our left hand, and reduce the rotation speed from 150 to 50 on the X axis of our right hand. That's much better. Thanks for watching this demo video. If you're interested in using Experimenter for your own research, send us an email at info@silicolabs.ca.